Hi guys, in this video we're going to have a look at how we complete the square. So why is this process useful? Well, it's a way that we can solve quadratic equations like I've got down here, but most of the people use the quadratic formula for that because it's much easier to use. So the other benefit of completing the square is that you can find out the turning point of a particular equation, and I'll go into a bit more detail with that as we go through our examples, but that's probably the main reason why you would complete the square, is to find out the turning point if you were to plot these on a graph. So let's get started on this first example. Now, when you complete the square, it needs to be in this format, and in the exam it will probably say put this into this format. Sometimes it will say complete the square, sometimes it won't, but if you see this format here, it's definitely going to be completing the square, so it's also a little bit of a hint. Okay, now I'm going to ignore this number here, and I'm just going to concentrate on this bit for now, because this is where it gets its sort of expression, is when we complete this square. Okay, so I've got my x, that's fine, that's always going to stay there, and this letter here, a, represents the number, and the number is always half of what's in front of the x. Now I'm going to go into a bit more detail as to why. So again, I'm ignoring that, I'm just going to concentrate on this. So if I had that there, so again I've just halved to 10 to get this, okay? So I've got x plus 5 in brackets squared. Now if you were to expand that, and again expanding double brackets video if you don't recognise this, but you should, if you're on this video, which is a bit tricky, you should have already done expanding double brackets. And I expand them. So x times x is x squared, x times 5 is 5x, and x times 5 is 5x, and 5 times 5 is 25. Okay, so if I was to do that, and then look at these, when we simplify them, I have x squared plus 10x, because 5x and 5x gets you the 10x, that's why we half that. So we get the x squared, excellent, we get the 10x, excellent, but unfortunately I have this plus 25. Okay, I don't want that, I need it to be x squared plus 10x plus 10, and this is where this b comes in. This is just another number that we use. Okay, so I've got my x plus 5 all squared, so that bit's fine, but that generates this. So to go from this to this, to go from basically 25 to 10, I have to take away 15. Okay, and then that's it, you're done. Okay, that is completing the square. So just going to go over that again. Whatever is in front of the x, you half it to get this. So half of 10 is 5. Expand it to see what you have, which was here. And then how do I go from this 25 to 10? I take away 15, and that is just your number you have there. Okay, so I mentioned earlier about turning points. Okay, and this is what you can do. Once you have completed the square, like so, you can work out the turning point. So the x coordinate of the turning point is we're going to look at what's inside the bracket here. Now, just like if you were to work out what a quadratic equation is by factorising, exactly the same thing here. We need to make this bracket equal to 0. Or, in other words, what value of x needs to go in here to make this bracket 0. Okay, so all I'm going to do is say, right, x plus 5, I need that to equal to 0. And I'm just going to solve it. So I'm just going to take away 5 from both sides. So x equals minus 5. And if you check it, minus 5 plus 5 is 0. Brilliant. So my x coordinate of the turning point will be minus 5. Okay. And the y coordinate is a lot easier. It's just whatever this number is here, which is minus 15. Okay. So if you were to plot x squared plus 10x plus 10, that would be the turning point. And like I said, I'll show you here. So remember, a quadratic is always a curve, unless it's a minus x squared, in which case it's the other way around, it's just upside down. Okay. So here's the one for x squared plus 10x plus 10. I've plotted this on here, and as you can see, minus 5 minus 15 is where it turns before it goes back up. So that's why completing the square is useful, because it can tell us that. Okay, so I did say you can solve them, and that's what we're now going to do for this one here. So to solve it, just like with any quadratic, it needs to equal 0, which is what I've got here. Okay, so that was what we got when we completed the square. Minus 15, and I'm now going to set that equal to 0. Okay, then it's just simple rearranging. I'm going to plus 15 to both sides. So that leaves me with x plus 5 squared equals 15. Okay, like so. Then I'm going to get rid of this squared. So the opposite of squaring is square rooting. So I'm going to square root both sides. So that'll leave me with x plus 5 equals the square root of 15. Now remember, when you square root, there will be a positive value and there will be a negative value. Okay, so that's why I've put the plus minus square root 15 here, because there will be two answers to this. And then finally, to finish off, I've got plus 5 here. Do the opposite. We take away 5 to both sides. So that's x equals minus 5 plus or minus the square root of 15. And you will need your calculator. Mine's just over here to work these out. So minus 5, I'll do the plus first, plus the square root of 15. And obviously I'll come up here, press the SD button. I'm going to round mine to 2 decimal places. Obviously in the exam, it might ask you to round it to something different. Just read the question and obviously do that. So I've got minus 1.1 and 7 will round that 2 up to a 3. And then I need to do the minus 1. So minus 5, this time minus the square root of 15. Again, press the SD button. So the other solution is minus 8 point, and again I'll round that to 2 decimal places, which is 87. Okay, so that's how you find the midpoint. Well, that's how you complete the square, that's how you find the midpoint, and then that's how you solve it. Okay, let's have a look at another example. So here we go. I'm going to put this into this form here, so I'm going to complete the square. So again, I'm going to start off with a bit that I know, which is I need to half this, which is minus 4, and then the squared. So that's always your starting point. Then we're going to expand the bracket. X minus 4, x minus 4, x times x, x squared, x times minus 4, minus 4x, minus 4 times x, minus 4x again, minus 4 times minus 4, be careful, minus times a minus is a positive, so that will be 16. And again, if we write this out, I'll have my x squared, minus 4x is my minus the 8x. Brilliant, got the first 2 bits, but I do have that plus 16. So how do I go from 16 to 5? I need to take away 11. Okay, and that's it, you've completed the square. So let's find the turning point. So again, I need to set this equal to 0. So x minus 4, that needs to equal 0. So just a little bit of rearranging by adding 4 to both sides. You should get x coordinate to be 4, so x equals 4. So 4 minus 4 is 0. Excellent, that works. So the x coordinate is 4, and the y coordinate is just that minus 11 we had there. And again, if I just bring up my little diagram here, x squared minus 8x plus 5, this is what it was. So the turning point there, it was 4 and then minus 11. Again, so you can just see, if you were to have sketched it, that's the turning point there. Obviously, this just saves you having to actually sketch it. Okay. Right, now let's solve that one. So again, it's now equal to 0. So when we completed the square, it was x minus 4 squared minus 11. That's now equal to 0. So just like we did over here, just start to solve it using the balance method. So I'm going to plus 11 to both sides. So that leaves me with x minus 4 squared equals 11. Then I'm going to get rid of that squared by doing the opposite and square rooting both sides, which leaves me with x minus 4, remember that plus or minus the square root of 11. And then I'm going to add 4 to both sides. So x equals 4 plus or minus the square root of 11. Get the old calculator out and put it in. So I've got 4, I'll do the plus first again, the square root of 11, SD, so that gives me, again, 2 decimal places I'm going to do here, 7.32, x equals 7.32, and then do the subtraction one, so 4 minus the square root of 11, yep, and again I'll do that to 2 decimal places, 0.68. Excellent. Okay, and that's the basics of it. Now there are a few other slightly trickier ones to just be aware of, which we're now going to have a look at on my next sheet. Just bear with me. Okie dokie. So here we go. I've got 3 more examples, just illustrating some slightly different points here. So this is going to be exactly the same. It's going to complete the square exactly the same as we did before. Remember, half whatever's in front of the x squared. Then I'm going to expand the bracket. X plus 6, x plus 6. That leaves me with x squared plus 6x plus 6x plus 36. Okay, and again, when you just write that out, I'll have x squared, I'll have my plus 12x when I add those two together, and I'll have my plus 36. How do I go from 36 to minus 5? Well, I'm going to need to take away 41. Okay, and now let's find the turning point. So what does x need to be to make this bracket 0? Again, you can set it equal to 0 and do what I've done on the previous pages, but hopefully by now you can just spot, well, x will need to be minus 6 because minus 6 plus 6 is 0. So I'm going to have minus 6 for the x coordinate, and the y coordinate is just that there, the minus 41. Okay, so there we go, there's a turning point. Now, why have I done this example? Well, I've now set it equal to 12, okay? So in this case, it's not equal to 0, it's equal to 12, and I'm going to solve it. So, if I use my completing the square, and that equals 12, okay? Now, obviously, if you were using the quadratic formula, you'd have to make this equal to 0. However, doing it this way, you can just rearrange it straight from the off. So I'm going to add 41 to both sides, which leaves me with 53. Yep. And then I'm going to square root both sides. So x plus 6 equals plus or minus the square root of 53. And then I'm going to take away 6 from both sides. So x equals minus 6 plus or minus the square root of 53. So let's have a look what that generates. So minus 6 plus the square root of 53. And again, to 2 decimal places is 1.28. That's nice. And let's do the minus. So minus 6 minus the square root of 53. Again, 2 decimal places is minus 13.28. Fab. Excellent. Okay, so don't worry if it's not equal to 0 in this case. Just do it as you would do normally. Okay. Next one. What do you do if there is a coefficient in front of the x squared? Well, this does make it a tad awkward. So all I'm going to do is I'm going to factorise it out. Okay, so that leaves me with x squared plus 2x minus 3. Okay, so that's the first thing you need to do. Once you've done that, we can essentially ignore it for now, and we complete the square using this. So if I was to complete the square, I would have obviously my x, I would half 2x, so that would just be 1 squared like so. And then I would expand the bracket, x plus 1, x plus 1. So x squared, 1 times x is just x, 1 times x just x, 1 times 1 is 1. Okay, so that'll leave me with x squared, then it'll be plus the 2x, which is what I want, and I have a plus 1. Okay, I need the 1 to go to a minus 3. So what am I going to do? I'm going to take away 4. Okay, but you need to be careful because we've just completed the square of this bit that's inside those brackets there. There is still that 4. Okay, and you cannot ignore it. You do need to actually address it. So all I'm going to do is then expand this bracket. So I'm going to do 4 times the x plus 1 squared, which will just leave me with 4 and an x plus 1 squared like that. And then 4 times minus 4 will give me the minus 16. Okay, so it's not a problem. You just take it out by factorising, complete the square, and then just put it back in at the end, and then you'll have the right answer. And again, we could just have a look at what the turning point will be. So again, what would x need to be? Well, x plus 1, so x will need to be minus 1 to make that bracket 0, then all that will be 0. Cool. And then y, what does y need to be? It's just that number there, minus 16. Okay, so the turning point there, minus 1, minus 16. Again, when we come back to here, this time it's equal to 0 again, so it's not a problem. So if I complete the square of this, even though it's got the coefficient in, I've already dealt with it because it's now here. So I can just substitute that straight in like so and set it equal to 0. Now there's going to be an extra step here because obviously we haven't seen this before, but we just treat it as we're solving a normal equation. So I'm going to add 16 to both sides. And that'll leave me with that. Okay, I'm then going to divide by 4. I'm not going to square root yet, I'm going to divide by 4 to get rid of that, which will leave me with x plus 1 squared equals 16 divided by 4 is obviously 4. Lovely. Then I can square root both sides, which will leave me with x plus 1 equals the square root of 4. But remember, it's plus or minus. Now, obviously, you can just do root 4 as 2, but I'm going to leave it like that, just so it's in the same format as this to put into a calculator. It's up to you. You can do it the other way around if you wish, but I'm just going to leave it like that. And then I need to minus 1 from both sides. So x will equal minus 1 plus or minus the square root of 4. Okie dokie. Let's put that into our calculator and have a look. So minus 1, I'll do the plus first, plus the square root of 4. So the first solution we have is 1, x is 1. And then minus 1, and I'll do the minus the square root of 4. And then the other solution we have is x is minus 3. Okay. Yeah, lovely. Excellent. Okie dokie. And the last example we're going to have a look at on this one is this one here. So again, I have a coefficient, so I'm going to do the same thing that I did here. I'm going to take the 2 out temporarily. And you might notice this is not very nice, so I'm going to do that as a fraction, just 5 over 2. Okay, now if you want to put that as a decimal and have that as 2.5, that's absolutely fine. I'm going to keep it as a fraction, but both ways are fine. Do it as a fraction or a decimal. Okay, so let's get cracking then. So let's start to complete the square. So I'm going to have my x. I'm going to half this. So again, 3, and if I half it, that'll be 3 over 2 squared. Now again, you can put that as a decimal, 1.5, absolutely fine. I'm going to keep it as a fraction just for now. There's no real benefit of using either way. Maybe fractions are a bit easier, I think, when timesing. Some decimals might get tricky, but if you've got a calculator, it's neither here nor there. Okay, so let's now expand that bracket. So x plus 3 over 2, x plus 3 over 2. And then we've got our x squared, and then I'm going to have 3 over 2x, 3 over 2x, and 3 over 2 times 3 over 2. This is why I keep it as a fraction, because when you times fractions, just times the top times the bottom. So 3 times 3 will give me 9, and then 2 times 2 will give me 4. So when I write that out, I'll have x squared. I'll have my 3x. Oops. Well, a bit bigger. And then I'll have 9 over 4. Okay? Now, how do I go from 9 over 4 to 5 over 2? Well, when you're comparing fractions, you need to make the denominators the same. So I'm just going to times this one by 2 to turn it into 10 over 4. So denominator is now the same. So how do I go from 9 over 4 to 10 over 4? I just need to add 1 over 4, 1 quarter. Okay, so the 1 quarter plus 9 quarters give me 10 quarters. And there we go, I've completed the square. So again, the turning point for this, I'm just going to have minus 3 over 2, because minus 3 over 2 plus 3 over 2 gets me to 0, and then the y coordinate there will just be a quarter. Oh no, sorry, I've fallen into the trap. Remember, once you've done that, we need to times it all by 2. I needed it here, exactly the same thing. Don't forget about it, you do need to put it back in. So actually that's going to be 2x plus 3 over 2 squared, and then 2 times a quarter will be 2 quarters, which is a half. Okay, so we're still going to have minus 3 over 2 as the x-coordinate, because that doesn't change, but the y-coordinate will be a half. Oh, nearly fell for it. Okay, so yeah, make sure you do go back and do that. Don't do what I just did and forget about it. Okay, right, now we've got that turning point, let's try and solve it. So again, this time I've got it equal to a number, but I've already completed the square, so I can sort that out. So we've got 2x plus 3 over 2 squared plus 1 half, and that will equal 12. Okay, and just like we did here, minus a half first to both sides. So I'm going to have 2x plus 3 over 2 squared, and then that'll be, 11 and a half. So I'm just taking away a half. Then I'm going to divide by 2. Both sides, so I'm going to have x plus 3 over 2 squared, and I am going to cheat just so I don't make any silly mistakes. 11.5 divided by 2, and that's going to leave me with 23 over 4. Okay, again, you can put it as a decimal if you want, or if you want, I'm just going to leave it as a fraction. And then I need to square root it. Square root both sides, so x plus 3 over 2 equals plus or minus the square root of 23 over 4, and the last step, take away the 3 over 2 to both sides. So I'm going to have x equals minus 3 over 2 plus or minus the square root of 23 over 4. So it does get a little bit interesting. So let's do this. So minus 3 over 2 plus the square root fraction button of 23 over 4, and then let's see what that comes out with. So again, if I do this to 2 decimal places, 0.897, that's 7 around that 9 up. So I'm going to have x equals 0.90. And again, let's go back. You can just press the arrow back and just change that plus to a minus, but I'm just writing it out so you can see how you do that. And this time I want to take away the square root of 23 over 4, and that is minus 3.897. So again, that's 7 will round that 9 up, so it's going to be minus 3.90. Excellent. Okay, so that is how you complete the square. A few tricky ones here. Just be careful of the coefficient. Again, just make sure you do go back and put that in. Yeah, hopefully that helps, guys. It's a good topic, this. Hope it helps. Thanks for watching.